Hey everybody, this is Michael from Bright Musical Circuits. This is the schematic for the new parallel melody generator. This is the full schematic right here, which is so many lines that cross each other that it can look very confusing. But this is actually a relatively simple module because it's pretty much just a microcontroller that has digital inputs and a digital output. One thing on the schematic, you see these pad 6, pad 7, etc. things. Those are the wire pads that take the panel board to the top board. So the panel board is the one that has all the jacks and the switch, and then it also has some of the input circuitry and output circuitry on it. And the top board has everything else. In addition to this big schematic, I drew simplified versions of the inputs and outputs. We've got these, so on the left side of the screen, you'll see all the input jacks, and these are all set up pretty much the exact same way. It's a jack. It goes through a regular switching diode here, which is going to make it so only positive voltages pass. And then there's a 100K resistor to ground, that's going to act as a pull-down resistor. And then this diode here is a Schottky diode that is connected to plus 5 volts. And that should push any voltages over 5 volts, just short them to 5 volts. And the reason we have these two diodes is just to protect the input pins of our microcontroller, which giving it a overvoltage or an undervoltage can sometimes cause issues. But because we're only digital inputs, it's a little less sensitive this time. And honestly, if you have a system that all your gates are plus 5 volts, or all your LFOs are never go above plus 5 volts, then you're probably okay just like leaving these Schottkys out. They're not that expensive, but if you are like, trying to be budget conscious, then you can do that. And I should point out too that this is shown as a 100K resistor to ground here. In reality, these are part of a resistor array. So this is a bus array up here. Pin 1 connects to ground and connects to one end of each of these resistors. And then these resistors are all connected to the input pins of the microcontroller. And I have it set up with two bus arrays that are doing the same thing. It was just easier to lay out the board if you use two arrays on either side of the chip rather than having one really long array. So the only inputs other than this, the two little changes are our update input jack. That has this plus 5 volts that is normalized to its switch. So that way, if you don't have anything plugged into the jack, plus 5 volts gets fed straight through to the microcontroller. And then we also have digital input pins that are being used to monitor this toggle switch down here. So this toggle is selecting our mode. So that's going to pins 10 and 12. So it's a on-off-on toggle. So when it's in the middle, both pins 10 and 12 are going to be at ground, and it'll be in major mode. And then if you flip it one way, it'll put plus 5 volts to 12, and flip it the other, it'll go to 10. And that selects either chromatic or minor mode. That's basically all you need to know about the inputs. The microcontroller, this is the pinout for it. This is all in the documentation. But so the outputs of it are going to be these pins 8, 9, and 11 that go to our 4921 digital to analog converter chip. So here we see those pins here, and one is providing a clock, one is providing the actual data, and then one is just telling it when a set of data is starting or stopping. And we have a plus 5 volt regulated supply here that's powering this chip, and then it's also providing the positive voltage reference, and then our ground is providing a ground reference, and we have a output from it that just goes straight into an op amp, and then there is a pair of resistors in that feedback path that are going to set the gain of this. And I used a TLO72 that I'm just not using half of. I end up having a lot more TLO72s than TLO71s, and It's easier for me to just use all TL072s. Yeah, the output of this goes to this 1K resistor to the output jack. And that's pretty much it. This is a Cermet pot here that you would adjust with a little screwdriver to set the octaves to be exactly 1 volt apart. And after you've done that, you should have a perfectly calibrated module. So yeah, the only other thing that I didn't go over is the power supply, which is, it's the same thing I do with most things. 10 ohm resistors, some capacitors for the op amps, and 10 UFs for your big filters, and then a 7805, or this might be a 78L05 when it's in the store. The Eagle has weird part names for stuff sometimes. That then is providing your 5 volt reference. And then that's about it. It's pretty simple. It looks confusing to read as a master schematic, but once you know how everything works, it's an easy one to do. So yeah, thank you for watching.